into Python code. We don't have it right now. We need to have it. And actually, one of the goals that I put for today is to actually transform that section into code. But anyway, continuing on the scientific workflow, a key thing on any research program is to have a hypothesis. The hypothesis that we have on that research plan is that when you calculate that metric, you could sort of flag certain grants that could be colluding or not. The hypothesis that we have is that when you look at that metric, you would be able to see clearly that there are a lot of grants that, let's say, that metric is on the low side, and another cluster that would be on the high side. The ones that are on the low side would be the colluders one, while the ones on the high side would be the common ones. The basic idea of that is that we suppose that colluding actors, they try to optimize their funding, while common grants, they don't try to optimize. So in a certain sense, we have the hypothesis that, let's say, grants that are super optimized are potentially colluding. But of course, this is an interpretation and depends on the definitions. Let's say this is always subject to change. And one of the key ideas of have the academician session to have community involvement is to make the community able to question that. And also to, let's say, give us those indicators that they think that maybe the better proxies for what is colluding behavior. But anyway, in order to have a scientific workflow, we must have a structure. And this is the initial structure that we have so that we can execute the research plan. And as you can see, having those public work sessions makes part of that. There are a set of applications here that, let's say, could turn into actually policies or not, and also next steps that we could do anyway. But this is a basic overview of the research plan, and we can discuss a bit further afterwards. And
so I'll make a comment about the future. So
yeah.
the research is, discovery, and it includes the subjective questions about definitions. But ultimately, the goal from Gitcoin's perspective is to have meaningful policies for identifying collusion and sort of mitigating it as a risk, but because the quadratic funding algorithm itself is susceptible to collusion. And in this case, the idea here is that the data itself doesn't represent collusion. The collusion is something that you can think of as requiring intent. So at best, our algorithms can flag things based on this notion of optimality that we're proposing, or other notions that we might discover through this research, to say that this has a higher risk of collusion and therefore merits a human inspection. So we're actually talking about a joint workflow between a algorithmic flagging type algorithm alongside sort of a social or human review type procedure. And that actually, because of the inherent subjectivity of the notion collusion, we have, and we observed this in one of the short articles we wrote, that we can't reduce the notion of collusion to an artifact in the data. We can only use the artifacts in the data to identify something that was potentially collusion or merits review for collusion, because the ultimate decision is normative. So separating the sort of algorithmic and normative components of the question is a part of the research that led up to this. So now that we're there, we're focusing on this algorithmic component as a sub-step to feed into, the scalability of the normative component, the human review process. Because obviously, as Gitcoin grows, they can't evaluate everything on an individual basis, but you can use algorithms to select the subset with the highest probability of being collusion, or with the most optimal matching. Basically says, hey, well, if this had been collusion, it would be a big problem because they're extracting a lot of money, but maybe they happen to be extracting a lot of money and it's just a consequence of reality, that they just had a lot of supporters, or you get the idea. So just separating the normative and algorithmic components appropriately is really important for scoping the research.
I just wanted to offer the opportunity for anyone to ask questions, or kind of if there's any bigger context level questions, how this fits into kind of the Gitcoin Grants ecosystem. Or I'm just guessing some of the people here may be seeing this for the first time. So if there are any questions or context needed, definitely feel free to open up.
I mean, in terms of how to define collusion, Danilo, it sounds like you now take a first approach in identifying via neighboring subgraphs, but this is just, probably there are many more, let's say, definitions of collusion which can be explored via various methods, right?
Yeah, that's right. And actually, this is the first item on the next step section.
Okay.
So if the task is sufficiently motivated, the goal of this session was to actually do live coding, and so that's going to be Danilo driving. But because it's the first one, we wanted to make sure that like there was enough level setting that we weren't just coding for coding's sake, that we're like doing science, we're solving policy design problems, we're doing token engineering in the sense of, at least I use the term engineering to distinguish the sort of social responsibility aspect of technical work, right? Like we're building things for people. And the for people part is what we kind of laid out here. Why are we doing this? How does it service this community, et cetera? And then diving into the meat of it is, sort of research and development of algorithmic policies.
Yeah, just to finish the presentation here, I just want to have a very quick look on the repo. And actually, if you guys want to already dive into the code, if you have a look on the TA Gitcoin channel, I have created a live share session that is hosted on my computer. I've already verified there is no sensitive data. So, I mean, if you guys want to already dive in and have VS Code, the session is already open. But anyway, I'll share my screen here quickly, just so that I can show the repository here. Okay. So this is the last part of the presentation before we actually get on the VS Code. But the output of this research is going to be published at an open source repository at GitHub, at the Gitcoin cadCAD model repo on the gitcoin.org. So if you guys create any branch, create any new kind of analysis, maybe any kind of modifications to the model, feel free to fork it up and create a pull request. But of course, we can work together on the live share session too. And just to give a very brief overview of the structure, here we have a cadCAD model that generates a network of the Gitcoin Grants state for each point on time. And the way that this is done is through the model that we have put on here on the folder. And just to show very in a brief the structure of that, if you go to the partial state update block, you can see the, let's say, the execution structure in the sense that, let's say, you have a first block here that on each point on time, you have a network graph and you keep appending new edges. And when I mean edges, I mean contributions, because on Gitcoin we have nodes that represents grants and nodes that represents contributors. So for each time we add new contributions. And also for each point on time, we also calculate some metrics, like, for example, what is the quadratic match and funding for each grant. And there is also this one where we calculate what we call the simple quadratic funding. So this is sort of a counterfactual version of the quadratic match, where we have removed a certain term there, and we want to see how the network behaves. And the idea is that, let's say, by using that simulation, we can generate data sets that contains a version of the network of the Gitcoin state for each point on time. And actually, this is located on the data folder here on the model. So if you clone that repo, you already have access to the round 8 data. We have created the data so that we don't dox anyone. We have already triple checked it, so it's pretty safe. And the idea is that in order to run the simulation, you would need to execute the run simulation here. There is a whole explanation here of how you do that, and I will skip it for now. But the idea is that you generate a pickle data that contains, let's say, the simulation results. And you would use Jupyter notebooks for performing the analytics. So, for example, for the posts that we did for the Gitcoin Science before, we have that dynamic network notebook and the graph communities. And I can show it quickly. But the idea is that we, as a through our working session, we'll be mainly working on the optimality gap notebook. And I'll show it too. And also the optimality gap folder where we'll have our definitions, we'll have our functions, and so on. Let me see if I have a... So, for example, this is a notebook where we have consumed the result of the simulation. I'll go it quickly because I want to actually start work soon. But the idea is that on every notebook we load the data from the simulation here, and we could perform any analytics like we would like for example, summing the contributions for each contributor grant pair, doing some plots, and so on. But I really want to skip a bit the explanation of that notebook now. Here, for example, we could see how much communities we can detect along the time. But we have a whole blog post explaining that. Anyway, the link for this repository is on the Gitcoin channel. So if you guys didn't clone yet, didn't fork yet, I recommend you to do so because we are going to use it a lot. And about what we are going to work mostly on this optimality gap notebook. I already did some preparation here so that we can feel more comfortable with working. So, for example, I already imported some libraries, and actually this is a fun notebook because this is the first time that I use HoloViews, and actually I thanks Joe for showing it. It is a very useful library, and here I load the data. And one thing that I did here to make it a bit easier for onboarding is that on these sections here, I already have a graph head, a network X graph head for playing with. So what I do is the following. When I load that pickle here, I have the results of the simulation. It means that I have one network X graph for each point on time. So if you have, for example, 1,000 points in time, it means that we have 1,000 network X graph objects. And actually, those network X graphs are generated, are loaded here. And on block 6 here, what I do is to select the network X graph that corresponds to the time sequence 50. And I have a function here that visualizes bipartite networks that we have used on our first blog post. Well, this is the visualization for it. So on the left side, we would have the contributors. Actually, I'm thinking here if the color is not exchanged, but yeah, let's suppose that select here is simply contributors. So you can see the colors here. The right one would be grants. And those lines means the contributions between each contributor and each grant. And the size of the nodes is the amount that they received in USDT. So this is the state of the Gitcoin Grants round 8 after the, let's say, the 50 contribution. And we could look at that with HoloViews, but for some reason, GitHub didn't show. I think that I have it ready here. Let me see.
And Danilo, the dot of the contributor, the size of the dot is then also how many a contributor ever received or sended.
The size is the amount is the total contributions. it
Okay.
isn't related to the number of contributors. It's the amount, the sum
Yeah,
of
so
amount.
on the left side, we have then total sent, and on the right side, total received when it comes to the size.
Yeah, on the right we have the grants, and on the left side we have the contributors.
Yeah, got it. I was just referring to the size of the dot, right? The size of a contributor. Is it then the amount sent, the total amount?
Yeah. Yeah, when you see the contributors, you inverse. So the size of the contributors is the amount that they have sent.
Yeah, that's it. Thank you.
So, yeah. Yeah, so I'm opening here my Jupyter Lab instance because I had a very nice plot with hollow views. Okay, so this is exactly the same thing as the previous plot, but by using hollow views. And you can see here that the blue nodes would be contributors, and actually when you go, and the black ones would be grants. And it's cool because when you hover, you could even see the total amount that was received or sent, and also you could see the name of the grant. And if you hover over the contributor, you also could see the name that was cryptographed. So we did some privacy pre-processing to make sure that nobody is personally identifiable. And the index that you are seeing here is a very complicated hash that has no relation whatsoever with the ID. So we have to take care to protect people's privacy. And well, that's the status of the notebook. I have tried to put here a structure that sort of encapsulates the research plan. So I have put a section here where we could put the definitions, another one here where we would optimize the graph, another for analysis, maybe another one for writing conclusions. And well, it's sort of a white canvas, so we need to fill it in. Well, this is the intent of the working sessions, actually. Before moving on, do you guys have any questions, any considerations? Just one observation that I would like to make is that our intent is that those working sessions they be more straightforward on the next times. It's really because we are introducing now, we need to level off and provide a contest. But the idea is really to, let's say, have a more hands-on approach. But anyway, any questions, comments, things that you guys want to talk?
Yeah, Danilo, I just want to say great work with the foundation and this canvas, and I've got it running here on my local system as well. So excited to start programming, and I'm also going to be sharing my screen, just in case anyone wants to tune in or needs help with, like, if anyone gets stuck on something, maybe I can help out as well.
Good. So, as I said before, the goal that I did put for today is to actually try to implement the definitions on the HackMD document. I think that I'm going to activate my hacker mode, and I'll try to work just like if nobody was watching. So, but anyway, you guys feel free to talk. If you guys, I mean, this is sort of an experimental thing. So, any suggestion, any thing that you feel that could work better, let's say, we're gladly hearing. And well, let's do it. So let me. So I'll share my entire screen so that you guys can see the entire thing here. So frame 15. Yeah. So are you guys seeing here my VS Code and the HackMD document side by side?
Yep.
Yeah.
Okay. So as I've said before, I'm hosting a live share session. So if you guys want to enter on my VS Code instance here, the link is on the Discord channel. So it's kind of curious because when somebody enters, you have multiple cursors, every one of them with different colors. So I mean, feel free to it. But anyway, the strategy that I'm going to adopt is the following. As I said before, we have this optionality gap folder here, where we have several files here. And I'm going to try to put the definitions here at the .py file. So the reason that I want to put on the .py file instead of directly on the Jupyter Notebook is that, well, first thing is easier to have version control. Second thing is, if anybody enters in the live share session, we can write together. There is a problem with the VS Code live share that you can collaborate on Jupyter notebooks, except if you use the .py notebooks. But I mean, anyway, this is just a knowledge share, and I think that one of the goals of those working sessions is to make that knowledge flow. So, I mean, you are really entering into our minds here. But anyway, as I said, my goal is to fill that definitions.py, but we have also other files here that I could describe a bit. So I'll go to VS Code because I think the idea is it's prettier. So there is also this functions.py file here where I put some, well, sort of like helper functions. I mean, there is always that phase when you are developing that you have functions and you don't know exactly where to put it. So that's the place where I'm putting them for now. But we have two functions here. Where one of them is the total amount, where we provide a graph, a network X graph, and we provide a node label, and it returns us a real number. And what it does is encapsulated here at the comment. We get the total amount USDT. It's a simple function, but we use a lot, so it's good practice to have it somewhere. Another function that I've put here, and actually I just copy and paste from the model, I simply, for some reason, I found it to be more clear to put it here too, is this contributions to graph function. Essentially, what it does, it picks the result of the result of the simulation of the cadCAD because actually, I'll show that on the code because maybe it's easier. So as I said, here at that block, I loaded the results from the simulation, which is a pickle file. Well, we use pickle because it allows us to simply store anything, especially if it's not tabular. But the idea is that we have this data frame, which we got from cadCAD. And what happens is that for each time step, we have these contributions here. Probably I can show it. Let me pick the first one, for example. Actually, I need to do that. Query time step equals 0. And contributions. I think maybe it's 2. Yeah, exactly. Anyway, at the first time step, we don't have any contribution whatsoever on Gitcoin. When we go to time step 1, maybe there is a better way to do that. Maybe if I use ulock. Okay, now it's nicer. But anyway, so as I said, when we pick the first time step, which is actually lock 0, we have no contributions, and well, I think this is sort of expected. When we go to 1, we have 1 contribution, and when we go to 2, we have 2 contributions. So this represents all the contributions that we have on a given time step. And what the contributions to graph does is that it gets that list from that column. So I would pass, for example, you can see my, I'm doing that here. There is the plot contributions function call here. I get the contribution series, I apply, I look at the graph index, and, oh no, actually it's the contribution to graph, I confused myself, sorry. Okay, so here. So we have the result contributions, and get the contribution series here. And when I apply the map function, I'm essentially, what I'm doing is to get that function and apply to each element on that series. And what these functions do is, when you look at the signature, is to get that list and transform into a network X graph. So this is it for the functions that we have on the functions file. Just to finish explaining a bit here, we have also another two files here, the quadratic match and the subgraph optimizer. The subgraph optimizer, the idea is that you provide a subgraph, which is actually a network X graph. You provide a function, and it's going to return you two things. It's going to return you the, let's say, the subgraph that optimizes that utility function, and it's going to return the score for it. And if you look at the HackMD document, this actually encapsulates definition 5, or at least sorts of try. But the utility function is actually the quadratic match. When I mean the utility function is the quadratic match, we have that implemented here on the quadratic match here, where we have, for example, the quadratic funding here, and you provide a graph. Actually, the utility function is that. And how it works, the utility function? You provide a graph, and it returns you a real value. And how this is calculated? You have a graph, a threshold, you calculate the quadratic match for each grant, and you take the sum of it. This is our utility function. Our utility function is the sum of all the quadratic matches for the grants contained inside a given graph. Anyway, any questions so far, or something that you want me to dive a bit deeper? I'll do those questions every 15 minutes, just to make sure.
One thing I noticed, the requirements file is missing the hollow views. So we can make a small update to the repo, but yeah, exactly. So if anyone's running this locally,
good call.
You might just have to pip install hollow views for now. Yeah. Or add this to the requirements file.
Yeah, that's a good call.
One question
Good.
regarding I have a question regarding the utility function. Can you pull up the definitions again?
Yeah, here at the.
So, D2.
You want the definition of the utility function?
D2. So that means that overall of all the grants consent. Okay, so this is the sum of all the grants. So you are looking at the total grants round, and then combining all the quadratic matches of individual grants, correct?
Yeah, we get the, let's say, subgraph, and that subgraph has several grants. We take the quadratic match of all of them, and then we take the sum. And this would be the quadratic match of the graph.
And at the moment, this is based on a single grants round, or is the data you have in the data set containing all grants rounds combined? So you had 8 different rounds of.
I think that there are. Let's say this is sort of a definition of how we calculate the quadratic match of a graph as a structure. What happens in practice, and actually this is what we are really interested to looking into, is that any graph can be breaking down into several subgraphs. So we can calculate the quadratic match for the entire graph by following D2. But what we want to accomplish through the research plan is to actually, for each grant, we want to calculate the neighborhood subgraph. So if you have, for example, 20 grants, we are going to get the Gitcoin Grants graph structure, and we are going to split that into 20 subgraphs that can be overlapping. And let's say each subgraph has its own score. And of course, if you take the whole graph, you could also have a score. But we are interested really in the neighborhood subgraph in speaking of research directions. Did it was clear?
Yes and no. So thanks for the additional explanation. What I was referring to is the grants round. So Gitcoin is running cycles where grants and quadratic match is collected.
Trotzdem, weil wenn ich da $6 stehen habe, denke ich, oh fuck, das sind ja $60.000, die ich da habe, geil.
So you know,
I didn't get exactly the question.
Yeah. So Gitcoin is running, is collecting grants, or the individual grants. We have kind of campaigns, grants, rounds. And the last campaign was in November, I guess, and it was round number 8. And my assumption is that certain metrics are not carried throughout all the rounds, but start from 0 or start from a certain metric and then start measuring. For example, the matching starts from over and over again in every single round. And I was just, okay, what's the logic you've implemented in the model or you are aiming for the rounds? So is the quadratic match?
I think the question is about the data set. Is the data set specifically for one round or is it for all rounds together? And is that the right question, Angela?
Yes, it is.
I believe it's just for round 8. Is that correct, Danilo? We're working with the data set, including the last round.
Yeah, exactly. It's only about rounds 8, and most probably each round is going to require a different definition because the current implementation of the quadratic match for rounds 8, I think it's different from the other ones. I'm not sure, but I suppose so.
Yeah, I believe Gitcoin has done some upgrades from round to round, so I think it's really only pertinent to look at the data on a round-by-round basis. So I believe this is looking at the data from round 8 in its entirety. Thanks for the clarification.
Yeah, I have input here on the methodology so that we have it clear. So, okay. Well, as I said before, let me go back here to the view mode. One of the goals that I had was to actually implement that definitions in code. Well, we could go through it. So let me put the two here side by side. And let's go to the definitions file. And let's think a bit about it. So first we have that full contribution graph, which we sort of already have. So I won't be implementing here because I'm simply assuming that we must get it from the other functions. The first definition that we need to have is actually this one, the neighborhood subgraph. Given a grant, we must have that subgraph. And well, one thing that I like a lot when I try to develop Python things is to do what I call Python pseudocode. Essentially, it's something that resembles Python, but I don't make any assertion that it's going to work. I just write and, well, later I try to fix it. But this really makes the development cycle very fast. So I'll go to C++ here. We have the neighborhood subgraph. And the first thing that we need is a grant. So, and I'll put that is string because most of the time when we call some node network level, I'll just suppose that is a string that we must pass. So I'll also put a pass here so that this code don't me error message. Yeah. Oh, breaking down a little. Let me see my connection here. I didn't quite understand. The voice broke down a bit.
I think you're good to keep going, Danilo. I don't know if anyone had a question.
Ah, okay. Yeah. By the way, is my voice going on fine? Because if not, I'm going to switch here my wireless connection.
It seems good now. It maybe broke up for just a small moment.
Okay. If you guys notice that my voice is breaking down or video is not going, just tell me. Okay. So we have this first definition here for neighborhood subgraph, where we take a grant as input here. And, well, I should have specified that on the document, but the thing is that the grant also depends on the contribution graph here, as you can see here. So I'll put that here. Contribution graph, and it's a network X graph. And let me import the network X here so that VS Code doesn't give me errors. And okay, those are our arguments and types, and this will return us another graph. I'll put here a placeholder for comments too, so I don't forget to write it down. Well, and that's the signature. And a lot of times, just by having a signature already helps to plan because you can create other functions that call on it, even if they don't implement it. And I'm going to write a pseudocode here. Let's say we have a neighborhoods subgraph, and it is equal to, let's say, I'll just put that. We can think about the functions afterwards, but I like to just annotate that because it makes it easier afterwards. A lot of time, I like a lot doing that top-down approach where first you care about the signatures and make sure that they're consistent, and then you work on actually putting the logic. And now there is the two here. The quadratic match of a subgraph is the sum of quadratic match of all grants combined inside it. And, well, just to make it clear what this means in Python, it means the following. Let's say quadratic match subgraph would be equal to some quadratic match all grants. And this would be a network X object. And all grants would be a list of some object.
Danilo, so here we have the sum.
Okay.
The sum of a graph
Let me think about it.
is returning a graph? Or
Actually, quadratic.
you have the sum of the quadratic match. Would that be like an integer or float? Yeah.
Yeah, that's right. Yeah, that's right. It was is that type. Anyway, a quadratic match would be. It would take a, let's say. Actually, this would be need to be a comprehension. Actually, I already have this implemented. I'm just doing that for showing how the process works. But we could do a comprehension here. So actually, we could call that the grant type. So this is really pseudocode. It's just to, let's say, to show how I usually do work when I'm trying to think about that. Is it clear for everyone why this must be that way? And did you guys ever some generator expressions before? So I will pick the definition that I put on the author file here, so that we have it more. I think it's on the quadratic match file. So yeah, it is that one here. Or better, we could simply do that from quadratic match. Now let's see the next definition here. So yeah, we have that the metric of interest is the neighborhood subgraph. So this could be simply a constant. Actually, let me think a bit about what that means. what I am saying here at B3 is that I'm going to use the quadratic match for a subgraph as the utility. So maybe I could make it that a bit more clear. Do you guys get what I mean by utility? Okay, so now we have the Hill subgraph and the optimal subgraph. And if we were going to write in pseudocode, I would say the following. Well, the Hill graph is simply the neighborhood subgraph to a given grant, so it will be the following. And let's suppose that we have a grant here. Maybe let's pick a grant here. I think that I'll select that bankless grant here because it's the first one.
Danilo, for D5, if you say, so
Okay,
that
now
the
we have an example
metric,
of the definition 4. The next step we have an example of definition 5. So the optimal subgraph.
Danilo,
Yeah.
can you hear me? Can you hear me? Sound is pretty bad. Danilo,
I didn't get Angela.
can you? Okay.
Could you repeat, please?
A question regarding D5. So you said where the edge connectivity is rearranged so that the metric is maximized. With metric, you are referring to maximum utility. So to the utility.
Yeah, that's right.
Okay.
Yeah, I was Danilo. You asked earlier if we know what you mean by utility, and I was trying to think, but I don't see it right here in front of me. Where was utility described?
So the idea here is that each subgraph can have a utility. I've put here on D3. The utility of a subgraph is the sum of the quadratic matches for all grants. I'm putting here.
Okay.
That's encapsulated between the 2 and the 3. I'll change here the 5 so that we can actually put that so it makes it more clear. So
in this sense, it would be subgraph for neighbors is the quadratic matching for an individual grant, isn't it? This is the metric.
The sum.
yeah,
The sum of the matching. Is that right? For For a neighbor subgraph?
Yeah. Yeah, that's the utility function for a subgraph of a neighborhood subgraph of a grant.
Yeah, makes sense.
So we are going to sweep on all grants. We are going to get the subgraph, the neighborhood subgraph for all grants, and we are interested in knowing what's the utility function for the hill one and what's the utility when you optimize it.
All right.
Well, the reason being is that in the end, let's say the metric that we want to investigate is the optimality gap. We want to take the fraction between the utility of the optimal and the utility of the hill one.
Okay.
So the optimal subgraph tem, it would be the, let's say, I have a function here that's, actually this function is not exactly working, but we can use it just as a placeholder. Okay, subgraph optimizer. So I have created a function here called optimize. Actually, it was me together with Emmanuel. And the idea of that function is that you give a subgraph as input, and you provide a utility function that has this signature I will explain shortly, and it returns you both the optimal subgraph as well as the utility of it. This function is actually not working because actually there are some nuances, and I'm almost sure that we are going to discuss it on tomorrow's session. So if you guys are curious because of why it's not working, I highly recommend to get on tomorrow's session. Probably it's going to be a fun discussion. It's sort of related to the traveling salesman problem, in the sense that you have, let's say, a complexity explosion. But I'll save the spoilers for now. Just to tell a bit about the structure of that utility function, the idea is that you provide a Python function, and that Python function, actually I need to remove that. Okay, now it's right. That Python function must have two arguments. It must have a graph, and I don't remember why I put a float here.
No,
actually we don't need that float. As I said before, we could run into bugs here, but no, it's correct. So I remember now. It was
callable. You have to put
I think because now I think it makes sense actually to be that, because
Danilo, I think Emmanuel.
Yeah,
I'm not sure if you can hear Emmanuel, who has some comments.
Yeah.
Go ahead, Emmanuel.
I don't know if he hears me, but I was just going to say that I did it like this because callable.
Yeah, Emmanuel.
The type of a function that, and then you put the types of the arguments of the function as a list.
I'm hearing you.
And then the type of the return after. So it receives a network X graph and returns a float. It's just a typing thing, static typing thing. That's it.
Yeah. Yeah, that's right. Actually, I have sort of confused. I was confused on the definition. So we have a list here of the arguments. So we only take a network network X graph as argument, and we return a float. And yeah, that's right. And actually, we could expand on that. I'll import the tuple here so that we have the signature here right. So actually, we would return a graph and a float. So as I said, that this encapsulates the optimization problem, but we do have some problems that it's not exactly working now. But anyway, we can put it here because at least the workflow will be right. So we call here the optimized graph connectivity, and we pass the subgraph, the Hill subgraph, and the utility function. And the utility function, I have defined here, I think. I was sort of testing that yesterday, so let me see where it was. Oh, actually, the utility function is just the total quadratic match, so never mind. So let's define it. Utility function equals lambda, and it takes a graph, so graph equals total quadratic match, and we provide a threshold, which is a constant number. So and I don't quite remember the number. There is this number somewhere on the simulation, but for now I will suppose that is 0.3. But here, so okay, now we have the utility function in place. So now, in terms of workflow, if we want to get the Hill subgraph on the optimal subgraph of the bankless grant, we already have things in place. Now let's see where we're in the HackMD doc. By the way, I just noticed something. So this is actually real match. Oops. Yeah, that's right. Because this optimized graph connective returns a tuple, so I forgot to unpack here. And we need also the Hill match, so it is quite simple actually. Okay, now it's done. Now we can define the optionality gap, and it's simple as that. So
Danilo,
in certain
there's
sense, we
a
have
little
the
bit
workflow for
lag between your
optionality
video
gap
and your
already
audio
in place.
for me.
In a sense, make sure that the function works as intended. But we already have something that yeah, go on.
You might want to try just refreshing the Discord call. It might help.
Switch the wireless here once, see if it gets better.
Sure.
Just give me. Okay.
in here.
Did you say something, Gavex?
Hey guys, I'm back. I was changing also the Wi-Fi connection, so maybe things will get better now. By the way, before we dive in further, do you guys have any more comments or questions? Just in having that 15-minute check, 5-minute check.
I have one question, Danilo.
Yeah.
So I'm just playing around a little bit in the notebook in the definitions section, just trying to keep up with where you're going, and I'm looking at this function that comes from. I've imported it from optimalitygap.quadratic match, and it's the quadratic match function. And I noticed that it in the for loop there, it gets the amount, which has the key amount per period USDT. But I notice in the graph that we have here, in this example, it doesn't have that field. It has a field that is just called amount. So is there some processing that happens between these? Or do you know why that discrepancy is there?
We need to refactor the quadratic match file actually. Let's say one of the goals of today was just to have the definitions in place so that let's say we can iterate, but we need to do some refactoring actually.
Oh, okay, so there's some steps involved, I think, that updates this field. Is that right?
Yeah, because what happens is that when you look at the Gitcoin data, if you look at the results of the simulations, you will see that there are some fields on the contributions, and one of them is amount per period ESDT.
Yep.
And on the subgraph optimizer, I mean, we could simply change that amount field to amount per period SDT. It would probably this would make it work, but it's really a refactory thing. And one of the intents of having the workflow is that we can try to hunt the code, get any errors, fix quickly, and move on.
Excellent. Okay. I'm gonna keep playing with this.
Workflow is that you run until it runs. So. But of course, this is a tactic that I adopted. Maybe there are other tactics that people use. For example, there are a lot of people that like writing a lot of tests, for example. And this is this is approach that some engineers use. But let's say my personal approach is to try to go top down.
Yep, I think we were going in a good direction with the hack MD doc. I don't want to pull the attention away too much, but I'm gonna be playing with the objects here as you're talking about them.
Yeah, good. So I'll share my screen here again. Okay, here we are now. So, okay, as I was saying before, we are sorting in the part here just before the hypothesis. I don't want to go to the hypothesis now because probably this is going to be more fun when we actually have the data. Let's say we actually have the optimality gap calculated. So actually the hypothesis part is always the fun part. But anyway, let's work so that we can make that possible. In order to actually go to the hypothesis, we need to have an optimality gap for each grant, because the hypothesis says the following. If you get the... And actually, I need to modify that document again. So because the distribution over rare. So I'll put here. The optimality gap per grant. So what the hypothesis says is the following. If we calculate the optimality gap for each grant, and we get the histogram of that, my hypothesis is that this is going to be a B-model plot. We are going to have a lot of points in one side, a lot of other points in the other side, and a gap in between. This is our hypothesis, and well, the thing about a hypothesis is that you don't agree or disagree. The only thing that you can do is disprove. If you are unable to disprove, then it doesn't mean that, let's say, it's true, but let's say it means that it's not false. And this is a key consideration in the scientific process. It's the notion of falsifiability. The idea is that you can only have a scientific process once you can turn things into false. You can never confirm it, but you can always turn it into false. So this hypothesis is a way that, let's say, we can turn something into false. And let's say if it's false, we drop that hypothesis, and if it's true, we have a wide range of applications and next steps that we could take on. How does that resonate with you guys? So in order to get the optimality gap for our grants, what we would do would be the following here. So, and probably, let me think a bit. So this is the optimality gap for a grant. So we could create a function for that. So the function would be grant optimality gap. And we provide the contribution graph and as usual, this would be a graph. This would be a label, and this would return us a real number. Okay, so that's it. Now we have a function here for the optimality gap. I'll add some placeholder for comments here as usual, so that become. And if I want to get the distribution of the optimality gaps, I would do the following. So let's say retrieve, or better, graph optimality gap distribution. Oh, just detected I error here. And well, that would be essentially an iterator. So just to put the types here, this one would be a graph. This would return us a list of real numbers. So let's put the comments here. And so let's suppose that we have a local variable here called grants. I'll define that soon. And for granting grants, actually there is a better way. Distribution equals to list of grant optimality gap for granting grants. Yeah, that's sort of it. And I'm thinking here how I get the unique grants on the graph. To tell you the truth, I always forget that network X methods, and it's kind of fun because I created a course on Coursera of how to use the network X, and I never remember the commands, but let's research it quickly. network X, get attributes nodes. I think that maybe one of the most underrated skills that one can have, tech skills, is being able to search Google quickly. So, NX, get node attributes, contributions graph. And the attribute, if I remember it quite well, I think it's type. There is something here. But these ones I am getting only. Okay. No, this is not right. Actually, this is the types. So grant the types. Now, I'm thinking here if there is a better way. Maybe what I could do is the following. Maybe get the contributions graph, dot nodes, data equals true. And this would return me a label and the data. Probably this is being a bit confusing because I'm sort of thinking the reverse order, but okay, I'll do a list comprehension. So grants equal node for node data in contribution graph dot data. Oops. Nodes data equal 3. Did you guys ever use did you ever access the graph nodes by passing the data argument before?
Yeah, so does this include the node attributes, something like that?
Yeah, actually this is a thing that I've discovered last week. The idea is that when you pass that data equals true, it will return you a sort of a tuple instead of a single element. And the first one is the label as usual, and the second one is a dictionary containing all the attributes. So I must put a conditional here. So if data type equal grant. I think this is it. I'll put a parenthesis here just to make it clear. That is There is a way also to make sure that we don't have duplicates. And it's really a quick thing. We just do that. Instead of having those brackets, we have curly braces. So that we use this set object of Python instead of dictionary. Actually, oh no, instead of the list, forgive me. Well, and essentially, this is the workflow in the sense that, let's say, what I would need to do now in the notebook is to simply call that graph optionality get distribution on the notebook. Of course, I don't know if my code is working because I didn't execute that yet, but we can try and we can see what errors we get into. So that's the fun part. I always love the error festival. So let's go on. In order to make things easy, as I said before, I already put here a graph here. So exactly that, the only thing that, let's say, hypothetically I need to do is to pass that G into the graph optionality gap distribution. So let's see if the luck zone is on our side. Actually, I'll change that section. I don't know, maybe retrieve optionality gap data. So now is the time of truth. So from optionality gap dot definitions, import graph optionality gap distribution. So let's see if we don't get an error. Yeah, there is always someone. So from type import I import a bunch because okay, let us see now. I think that one of the most useful features that had on Jupyter Lab last year is that button for restarting the kernel and rerunning everyone again. I think that I'll also comment that visualization so that it goes a bit quicker. So a quick trick is to just transform things into markdown blocks. So yeah, we did have our first victory today. We did import successfully, which is already something. And well, let's go to the next step here. So graph, optionality, gap, distribution. We could even have a betting market for those working sessions. So, oops, G. It seems it worked. Maybe not. There is something strange actually. Oh, okay, I got it. The thing is, when I did that list comprehension, I just returned the function for all grants. So, let's say the distribution of the optionality gap is a distribution of Python functions actually, but we fixed that. Now let us see. I think that there is another thing here that's taking time, that is mapping that. Yeah, first error. I'll just do a modification here because one key thing about when doing that kind of workflow is that it's important that execution time is quick because, well, if you spend 2 seconds in runtime, it's 2 seconds that you could fix better. So I'm losing 1 second here. And there is also the UX thing here. Ciao, ciao. I was just saying bye-bye here to a friend. So let me see if that works. Actually, maybe a better way would be to just do that. G equals research contributions 15 contributions to get. Probably this is going to be quicker. I think we need the lock. And remove that guy here. Yeah. Another thing that I always put on all my notebooks is this auto time extension. It's I think there is hardly anything more satisfying that you get to know how much seconds each block did take. And actually, I'm going to comment that extension because it's custom in time. That one too, and that one too. Just so that we can debug it quickly. So, okay, let's see our first error here. Grant optionality gap missing positional arm. It's on line 47, and that's a obvious one. The flowing, okay. Okay, did put on the Pluto. Now let's try it again. Non-type, probably. Let us see why. G, probably I put a none on the quadratic magical. So, okay. I didn't define the neighborhood subgraph. That was at the beginning of the working session, actually. So I guess that there is no way to run away from that now. So let's implement that neighborhood subgraph. And let's get back to the HackMD document. So as I said before, the neighborhood subgraph, the definition that we could take is that we select all the nodes, and I need to comment that HackMD document so that is more clear. Let me put that here. So okay. So for every node that is contained on the full contribution graph, we select every one where the distance from the node that is the argument is equal or below 3. And does it make sense for you guys? Why 3 and not another number? So what happens here is the following. Suppose that we have, for example, a grant. When you pick everyone, Iago, what do you say?
I think this is a collusion would be in this space because if you imagine one side of this graph, so the colluders are people. They're not. Oh, I guess it could be a grant. So a grant could be colluded, but it's also the participants who are investing in those grants are the colluders. So if you have one person and they have an edge to a grant, that's one distance, and then you can follow that grant and find another contributor, so that's distance of 2. So now if you take that contributor and find another grant that they have contributed to, that would be 3. So I guess this is connecting. This is sort of the minimum neighborhood size of a collusion instance, because we have different people. It's connecting 2 people and 2 grants. So it's this sort of collusion possibility. Is it something like that?
Yeah, that's exactly the idea. And of course, this is a definition that we are using, but one of the next steps is to okay, it's actually, for example, changing the one. So no, it's actually this one. Oh yeah, it's the one or here. Anyway, one of the next steps that we could have is that instead of having a degree-based subgraph, we could use, for example, community detection algorithms. And the main reason why we are using the neighborhood subgraph as being based on distance, first is that it is pretty intuitive. Let's say you have a grant, you get everyone that donated to it, you get the grants that they are also associated, and you pick let's say, the second order contributors. But of course, you could have some definitions, and like, for example, if you go to the network X, there are several ways how you could define a neighboring community. And let's say each one of those algorithms could be a research in its own. Of course, all algorithms have some limitations and also have some strong points. And it's never a trivial thing to select, let's say, because in the end, our algorithms sort of express what we think things should be divided into. But anyway, this is just a complicator that I wanted to put. But anyway, as I was saying before, we need to implement that because, well, there is no way to run away from that now. And this is actually one of the simplest cases that we could think of, so it's relatively easy to implement. So the way that I would do is the following. I need to get the network distance between 2 nodes. So as usual, I don't know what is the function, so let's search for it. Network distance between nodes. Shortest path length. This sounds promising. I think that's it. So the source would be the grant. And the distance would be the least comprehension for each node. So shortest path length. Actually, an X between source and target. For targeting contribution graph.nodes. And if yeah, that's it. And the neighborhoods would be the second. We would do that again. So and actually we did a map, so it doesn't make sense to do a list here. So yeah, target distances to source. Okay, so we're going to create a dictionary where we have the keys are the node labels, and the values are going to be the distance towards the source, which is the grant. Does it make sense?
Mm-hmm.
Okay, so let's get the neighborhoods. So the neighborhoods are a list where node for node distance to source, if distance equals or equal less than or equal to 3. So now we have the nodes, and now we get the neighborhood subgraph. So contribution graph dot subgraph and neighborhood. That's it. Does it make sense? Actually, I'm thinking here there is a problem. Oh no, it's alright. It's alright. I was just thinking about the subgraph, but it's good. By the way, are you guys familiar with what the subgraph method does when you apply to a graph?
So I think it takes the set of nodes that is a list that we're calling neighbors from the graph, and any edges that are between any of the two neighbors in that list.
Yeah, exact. You get, let's say, you get the original graph, you drop out all the nodes that are not contained on the argument, the neighbors, and you get only the edges that are between neighbors. So
Just
edges
muted.
that connect
You go in the
to
library?
nodes that are not contained here, those
Did you
edges
say
will be
something to me,
dropped.
or- Oh yeah. Oh yeah. Hey, dude. Yeah, there's a 3-hour hack session happening in the token engineering community.
Oh, nice.
Yeah.
So yeah, let's save the
Well, this
definitions
guy
here,
is
and
just
let's see if
showcasing
now
his
it
research
works.
that he's been doing for Gitcoin Grants.
Oh, cool.
Yeah, he's modeling the whole ecosystem as a network between, basically there's two types of nodes, grants and contributors. So there's an edge between a contributor and a grant if they've contributed.
Okay, now the node count.
But the goal is collusion detection. So
Let's see why.
because
The problem was on the
Gitcoin
distance
Grants
to
uses,
source.
quadratic funding. So the more people that donate to a grant, it gets like exponentially matched. So it's cool. It's like a funding system that it doesn't matter how much you donate to a grant. It's not like the more you donate, the more it's going to get funded.
So
it's the more
this
people
name here
that donate
makes
to it,
a lot
the
of
more it's going to get
sense
funded.
actually. So let me
So
try to trace.
Yeah. So really, you
I'm
just
calling
donate
here.
$1 usually. Like it's not really doesn't make sense to donate
You
much
have
more than
the
$1
grant of
because
Gap,
what you want to do is
so-
just get the number of.
Actually, this
Yeah.
name is a bit strange because this
Exactly.
is not a grant name.
Yep. So it's a cool sort of decentralized funding opportunity. And yeah, but the
How do I
idea is
put
like,
it
oh
trick
well,
here?
could that be manipulated? What if I just have
Let's
10
see
friends
what
and
it
I put up
gives.
some bullshit grant and we all contribute $1 to it? Now we've got $1,000 or something, you know?
Yeah.
So that's what he's doing, is this whole research project, collusion detection. So he's like halfway through the research, and
So it's
he's just
calling a strange source in there.
hosting
Let,
this lab
let me
session.
see if the
he's
signatures
just
are right.
He's just
So
coding for
okay.
like 3 hours.
Yeah, they're right.
And I think everyone's gourds are just. And other than me, I'm like, yeah,
And
this
the
is cool. This makes
source,
sense.
I
And,
think it's right.
yeah.
Not a lot of programmers in there.
Like I think there's probably a few, but they're not saying anything, and then there's a few others who just have no idea what's going on.
Gotcha.
Oh, shoot! This is part of the recording. Everything's being recorded
Let me double check that.
on my end. Even though I'm muted on Discord, it's I'm making a recording for this session.
Oh, okay. Sorry, man.
That's okay.
I'll be back around 5.
Okay, see you, Matt. Have a good one.
That's a strange error because it's giving us a source that, I mean, this would make sense if it is the target, not the source. Ah, okay, I got it. It was I've called it wrong here. So actually what happened is that I must provide the graph too. So contribution graph. Now I suppose that it will work now. Let us see. Let's see the next error. Okay, no path. So what we have now is that I suppose that this shortest path length algorithm, it supposes that you have a connected graph. If you don't have a connected graph, perhaps you have a problem.
It probably would like calculate only if you need to calculate the shortest path between any two nodes, the nodes have to be on the same graph, right? Like if the graph is not fully connected, then you need to do some steps. There might be some like clustering thing that you can look at or something.
There might be an all pairs shortest path function. I don't know if that's exactly what we need, or that we could use a function that checks if two nodes are that. Yeah, I think there should be like a is path or is there a path function. Or
I mean, I think that's a workaround that we could. Yeah, go on.
I mean, I think the final option, the hacker option, that you could just put a try except around it.
Oh yeah, yeah. Actually, I was thinking of the hatch option. I think it's simply quicker. So let's do it. Let's say def. How can we create a pretty name for it? Maybe robust shortest path length. And it takes a graph, a source, and a target. Actually, there is even a better option that is the following. Args, qargs. This is going to be very hacker. So try output.
This is awesome.
Actually, I think that giving a not a number is even more elegant. So now we have our robust shortest path length. we could even do a pull request on the networks library, telling that we have a generalization of their shortest path length function. So let's call it there. Oops. And I need to filter that. So now a quick question. If this number is not a number, is it lower or equal to 3?
You could return np.inf as the distance.
Yeah, good call. Oh, yeah, good call. We could even say that this returns as a float number. Just for clarity. So let us see if that works. Okay. Neighborhoods, too much values to unpack. So the problem was here at distance to source. Okay. I forgot the dot items. New error amount. Okay. Now we got on that error that you've been running before. I think that I'm thinking here how to best approach that in a quick way. Did you get did you do something about that, Shell, or not?
No, I abandoned it, but I'm sure we can figure it out here.
Okay, so yeah, we need to tackle that. So let's go to it. We need to do some archaeological service actually here. So so to tell you the truth, I don't remember what goes inside that contrib. Let's just print it and see what comes from it. So okay, yeah, I think that we just need to change that to amount because it's returning. Let's say the first one is being the. Let me see here. So the first one is grant, the second one is the contributor, and the third one is the dictionary. So that one would be amount. But now I need to make sure that this is being correct because that one is supposed to be 0. And there is this element here. Let me remember why. Yeah, probably I need to create a task to make that function a bit prettier. Well, just let's run as it, but I will comment here suspicious. This could be a contributor. So I like that so that I mean, I think it's important to flag things. So let's run it again. It's taking a bit of time, so maybe it's working. I just need to remove that print here. And probably I'm going to reduce I'm going to pick a grant at an early state because I think that the optimization algorithm can take a lot of time. And by the way, yeah, there is a problem here. So are you guys seeing those prints? So this is the print on that iteration, and what happens is the following. On the first one, we have a contributor at the first position, and a grant on the second position. And here we have, for example, a grant on the first position and a contributor on the second position. So it isn't suspicious. It's confirmed. So we need to tackle that. But for debugging purposes, just to see if the optimization is working and the workflow is working, I think that we can ignore that for now. But anyway, we know that we are not getting the right result as of now. We need to fix that before. So I'm going to select a graph here in a previous point, maybe 15. And let us see if it and also remove that. Actually, I'm thinking here if there is a way of also putting a progress bar. I love progress bars. Okay, I think here. So let me import here from the DGM, .auto, import. Did you guys ever use TechDDM before?
Yeah, I've used it. It's so cool.
Yeah. So let us see now.
Yeah.
Oops, division by 0. Okay, now that's an interesting question. What? Okay. I think that I was supposed to following it. Maybe if I'll put here a iterator. If the optimal match is equal to 0, then the optimality gap is not a number. I think this is a good definition. So if optimal match equals 0, actually larger than. Oops. Okay, now it's right. Let us see now. What is happening here is that it's because we have two ticket. Actually, I reset that. It's because when we optimize the subgraph, I also put a ticket DM. I think that if I put so here I'm on the subgraph optimizer file, and when I switch the edges here on the nodes, I also have some progress bar, but I think that I should remove them. So initial nodes. Let us see if it gets prettier. I'll try to pass that Livy argument, but it's a bit random argument. Actually, it's a bit strange. Sometimes it works, sometimes don't. That Livy equals false. The idea is that, yeah, almost working. I'll just drop it. But anyway, now we have our graph optimality gap distribution. Well, often it's not a number, but well, at least we have a workflow in place. So we got from the beginning to end to get the distribution of the optimality. Of course, another thing is actually calculate optimality. So we still need to do some things. Like, for example, I'm still not sure of that optimization function. We still need to test it more rigorously. Another thing is that we need to sort out that bug here. But, well, at least we got a list of numbers for each grant and, let's say, in just one cell block of the notebook. Now it's really to iterate on the bugs and, well, work on. So I think that we sort of accomplished the goal that I've put for today, and actually this is great progress for the research plan. And, well, do you guys have any considerations, comments? Also, another thing that I think that it could be useful for everyone, and also for the next working session, is also to share impressions and how you guys feel how it went and so on. So opinions are important.
Is there what would be the optimal sort of communication channel? Would there be some sort of forum somewhere, or just a particular Discord channel?
I think that the best channel would be the TA Gitcoin channel here at the Token Engineering. It's one of the bridges that we have. It's one of the communities. There is also a channel on the Gitcoin Central server, which is the same bridge actually. But I think those are the best ones.
And the repository is on GitHub as well, so people can fork and even make pull requests or comment issues if they find something that they would like to discuss, or if there's someone finds some sort of errors or wants to make some improvements.
Yeah, sure. The repository is going to be that one. And actually, I think that a final artifact that we could have that for that working session is to actually push what we did here. So let us do that. So I'm here at the folder of the Gitcoin repo. And, well, lots of things that were modified, so I'll add everyone. I'll create a commit here with a message. First working session with the community. And now push it. That's it. Everything that we wrote now is officially on the Gitcoin repo here. GitHub, Gitcoin code, Gitcoin cadCAD model. There's the link of the channel, so you guys can, I'll check it out later.
And just one more thing, Danilo, if you're able to jump back to the notebook, so it finished running there. Is there an output that we could see what the optimality gap was?
Sure. Let me show here again. So this is the final notebook for today, and well, it started like the first one when we began. And the great addition was that part. I've created that retrieve optimality gap data. We've imported the definition that we put there. Here we have the. Actually, I'll attribute that to a variable. So distribution equals that.
Mm-hmm.
And now we can inspect it. And the result that we have is a list of nota numbers. One thing that we could check quickly is to see if the length of the distribution is equal to the amount of grants. I think that this is a cool thing just to have a quick sanity check. As for why we have those nota numbers instead of real values, most probably is because there are bugs on the code that we need to fix. But anyway, just of having the workflow means that we can debug quickly.
Mm-hmm.
So Yeah, I'm going to remove here the comments so that we can run the full thing. And let's go through it. Okay, so this is the network. So we have something the order of tens of grants and 2 contributors. And what happened here? Forgot to load the extension here. Now let us see. Okay. And now running. Before that run, let's count how much grants we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14.
Danilo,
let's
can
see
you,
how much we have here.
what is the index at the beginning when you take the index on the graph?
Okay, I'll explain shortly. So we have 14 values here at least, and we have 14 grants here. So the size is correct. We just don't have the right values. As for the graph index, this is just to select, let's say, at what point on time we want the network. So here I'm selecting the network after the 15 contribution to Gitcoin.
So the data initially is like a sequence of contributions?
Yeah, maybe one way to show is that, for example, if I get the contributions at, let's say, graph index equals 0, we have nothing. If we get 3, then we have 3 contributions.
Yes, because this is the result of the simulation, is that right? Or
what the simulation does is to get the network, create an ordinal, create a network for each point in time. And also another thing that the simulation does is to calculate metrics on each point in time. So if we look at the result data frame, we also have several metrics, like, for example, the quadratic funding per grant, and also the simple quadratic fund, which is a counterfactor. Well, actually, if you look at the dynamic network notebook, you have several things just for that. I mean, if you want to have a better understanding of the simulation result, this dynamic network notebook would be the place. And there are interesting results. There is even a plot here, for example, where we calculate the Gini coefficient for the Gitcoin contributions, and how it was the Gini coefficient across grants. It's a very interesting notebook. Anyway, any more questions? And about
that was a really great
interactions,
session.
How do you guys feel? What is your feeling about the session? I mean, any suggestions for improving, or maybe things to consider that could be useful too?
I mean, maybe I'll leave the any comments for anyone with more expertise in this area. Definitely for me, I'm not, a data scientist or, Python coder. So it's really helpful for me to see and also have the discussion of 2 or more experienced coders asking questions that I wouldn't think to ask, and looking at, I think for me, it's just basically understanding better the different parts of how this all comes together. But I definitely would, as far as improvements, I'd love to open the floor to Jaja or Emmanuel or anyone else who has more experience kind of on the data science thing. What would help you, looking at these models, or any questions you have? Definitely, I think, speaking from a place of more experience than I have with this kind of stuff.
Yeah, cool. One of the intentions that we have is really to, let's say, to show how how the sausage maker works. So I mean, it's really about showing the process.
Maybe we should do a round with everyone and just get some thoughts and feedback or anything that came up over the session. And so Jeff, that was awesome. It's really nice to get perspective from someone who is so deeply involved with the outcomes of these simulations and the modeling, but not directly a Python programmer yourself and not directly working on the modeling. Yeah, I would imagine it's very helpful for you to see the process, how the sausage is made, as Danilo said, and the mindset, the kind of mental models of setting up this development loop, this feedback loop, and then getting to work through it.
Yeah, absolutely. And I mean, I'm more on the side of like explaining to people what sausages are and why we need sausages rather than building them. So it's great to be part of the process as well.
Yeah, exactly. Yeah, this will help you communicate. So yeah, I want so there was that, and I want to say that I think this is so cool. I think this kind of format will really push the field forward and accelerate the sort of educational capacity and the transparency, because we can hand over sausages to people, but they might be asking what's in it, right? So I think this is just really good across the board for all the participants that are involved in this, whether it's like clients or even users of the Gitcoin ecosystem, and the modelers and developers that are on this call, of course. And these sessions get recorded, so the value can really be unlocked over time. And so I really enjoyed this. Yeah, actually, Danilo, I just want to say I think really good job. Like the setup at the beginning, going through the HackMD file, I think that was a really awesome way to set it up so everyone could see what was coming and sort of what was the map of our journey that we were going through. So I'm stuck on the the bug. I can't stop thinking, okay, why is it all NaN values? So, but that's like a bonus, I guess.
We need a reason for people to come into the next working session.
Yeah, the cliffhanger. Yeah. Okay. So I think I'll pass it over. Maybe Santiago. Do you wanna say anything, or how do you feel about the session?
Yeah. Hi everyone. Yeah, it's a pretty cool initiative from you. I'm very interested in how you have modeled the Gitcoin grants and how we can try to model or different policies that would be like controlling these collusion events that it was usually happen on every grant. They have been happening on every grant. So yeah, I am really happy to be participating in each of these sessions, and they are really useful as well to learn more about how to apply token engineering and different and do data science on these different use cases. Yeah.
That's very cool, Santiago. And I think that you are going to appreciate a lot the academicians working session too. But let's say on this one, we did a tour on the sausage making factory. And on the next meeting, we are going to, let's say, to actually debate of what's the composition of the sausage. So it's sort of, let's say, creating sausage theories. So
cool.
So it could be a cool session to you to participate in. So stay tuned.
Great. Awesome.
And Jaja, how was your feeling about it?
Yeah, this is really good. I feel a lot more comfortable coding in Python now that I know you also search for syntax on how to on like the network X syntax, because I was like, what if when I have to show my code, I'm just like wiggling all the time. And yeah, it's like it turned out it's like it's really nice to like say so you like kind of like learn along the way, and I feel more comfortable just like be like learning and also doing things. And yeah, I think maybe I'll also look into if there's some interesting clustering algorithm to maybe see if I can contribute to this like this specific part. Also, hi everyone. I just joined BlockScience this week, and it's super nice to see you guys.
Nice to meet you, Gia.
Nice to meet you.
Yeah, great. And well, we've been talking before about the optimization, and let's say one of the bugs that we have, and probably is let's say one of the reasons of why we have that not a number, is sort of related to the optimizer. But anyways, this is a thing that we can discuss on and so on. And just a fun fact about that thing of searching the syntax and so on is that a fun thing is that I've actually created a course about networks X. So depending to where you ask for, let's say I think that I have here. Let me see, Coursera Network X. So this is the guy that searches for, let's say, for how to get the node attributes on Google because he doesn't remember. It's the guy that creates courses. So it's just a trivia. And there's a lot of learners here. But anyway, this is just to show how things are. The fact is, it's hard to remember things, and I think that one of the most useful skills that we can have is the skill of, let's say, of sort of identify the path that we need to get the knowledge. So a lot of times it's best for you to know how to search quickly rather than just memorize. So this is just a comment, and well, welcome abroad.
Nice.
Gavex and Emmanuel, how was your impressions about it?
Yeah, go on.
Manuel, can you talk first?
Yeah, go on, Gava.
Oh, my impressions was it's kind of hard to follow every step you made, especially for me who started to write code in Python. It was very joyful to me. I really appreciate every step you explain us. Thank you so much.
Yeah, great to hear that, Gava. And well, happy that you enjoyed the session. So, Emmanuel?
Yeah, I enjoyed the session very much. It was very nice to see the kind of flow of data analysis, of data science on the Gitcoin context. I think I feel sometimes that I am still wetting my foot, actually, so to speak. So it was very good to see a thought process and a development process on real data. It was very instructional. Very nice.
Oh, happy to hear that. And well, I think that we have sort of do the round robin. And well, so tomorrow we are going to have the academicians working session. It's going to be about the time now, so it's going to be. I never remember the time. We need to see the channel. And just to give some spoilers of what is going to go on, it is going to be really an academician session in the sense that the idea is, for example, to get on that HackMD document and get the metrics and, for example, question 10 or make suggestions, and also talk about more abstract questions. So, for example, one kind of question is the following. We have a method that optimizes the subgraph on our code, but it does having some problems. I'm not entirely sure that it does the right thing. And probably we are going to need to discuss that tomorrow because we may need to do some literature review and so on. So in a certain way, the academician's discussion, having a clear-cut research plan informs so that we can, let's say, do as a minimum of rework as needed, so that we, let's say, we don't need to, let's say, pick up the wrong algorithms. We pick the right ones at the beginning. And that's the way that I sort of see the workflow. While we develop this research, we'll generate data, we'll generate analysis and visualizations that will inform the directions. And at the same time, there is a work on the research side so that, let's say, our working time can be, or hacking time can be done as more efficiently as possible. So it's sort of a feedback loop that one informs the other. And, well, if you guys are available, I'm super happy. It's probably going to happen here at the Token Engineering Discord channel too. And that's sort of it. I think that we could finish there. And, well, I was super happy for the participation of all of you. I think it was a super great session. So I look forward to do it again when it's time. And I'll try to do an agenda, so, and, well, I think that's it.
Yeah, I really appreciate the open visibility into the pair programming process. And yeah, I think there's we have the recording of this, we can put it up I imagine if there's more interest in this initiative moving forward, then these can serve as sort of like a tutorial of sorts for people who are interested in diving deeper into these cadCAD models and learning how to improve them and build on them. Even this collaboration that we're in now, a lot of the work is yet to come to build these to be more robust models and answer more questions in the future. So yeah, thanks so much, Danilo, for walking us through that, and Sean for your participation and questions, and for everyone in sitting through this learning process. I think this is great, and I'm looking forward to the next one as well.
You've done well, Danilo. Congratulations.
Okay, thank you, everyone.
Yeah, thanks everyone.
Thanks, guys.
Until next time. Bye bye.
See you again next time.
Bye bye.
Yeah.
Bye.